Hello and welcome to Cannon County High School Algebra 2. Happy Monday to everybody. I think our plan this week, since this week would have been final exam week if we were in school, I think what I'm going to do is I'm going to make videos today, tomorrow, and Wednesday. And that'll be our last video because I think final exams, I think there would have been like a final exam makeup day on Thursday. So most of you would have been totally done with school by Wednesday. So I think I'm going to make videos today, tomorrow, and Wednesday, and then that'll be it. And then maybe on the last day, we'll see if Mr. Lyon here can lose his mask. You think we're safe enough to do that yet, Mr. Lyon? We'll see. Well, anyway, today we are going to talk about expected value again. And what we're going to be doing is looking at DD9, DD.9, which is called choosing the better bet. And they're just going to put two scenarios in front of you, and you have to figure out which one has the better bet, which one has the higher expected value. So Mr. Lyon, it won't be long, we'll be on summer vacation. You can take that off, go to the beach, have some fun. Let's take a look at DD9. Okay, let's see. Here we go. There are two different raffles that you can enter. Out of 1,000 tickets in Raffle A, each costing $14, one ticket wins $110. The remaining tickets win nothing. In Raffle B, which is at a carnival, has 200 tickets. Each ticket costs $7. One ticket wins $400. One ticket wins $290. One ticket wins $50, and the remaining tickets win nothing. Well, we've done problems kind of like this. All we have to do is figure out what's the better deal? What's the better bet, Raffle A or Raffle B? So we're just going to figure out the expected value of each one and figure out which one has a higher expected value, and that's it. Okay? So, I mean, this is the kind of thing that mathematicians get paid to do when they set up, different games of chance for different organizations or whatever, and not just games of chance, but you could think this is the way insurance companies set up insurance policies. You say, well, there's a such and such chance of this kind of accident happening, or this much of a chance of us having to pay out this much for somebody filing a claim with the insurance company. So we have to design our policy so that we make money, but at the same time, you want the policy to be attractive to the people so that they actually want to pay for the policy. Same idea here. All right, so let's see. Let's figure out the expected value. The first one says one ticket. Let's see, we have 1,000 tickets. Only one ticket out of that 1,000, one ticket wins the $110 prize. And the remaining tickets, which would be 999 out of 1,000, win nothing. So what's the expected value? The second one says, let's see, we have 200 tickets. Each one costs $7. Let's see. Well, let's think about this. Out of 1,000 tickets, Raffle A, each costing all right, do you see the problem with how I did this? Remember, this one, each one costs, I guess I didn't look at this very closely. This one, each one costs $14. So what's wrong with how I set this up? If you win $110, did you really win $110? No, you really didn't, because it cost you $14 to get in. So if you win, you really win $96, don't you? So let's do that again. You have a 1 in 1,000 chance of winning only $96 because it cost you $14 to get in. Plus, you have a 999 out of 1,000 chance. You're not going to win zero. You're actually losing $14. So you have to think about how much it costs you to get into the game here. So for scenario A, or game A, it looks like this, not this, is what we're looking at. All right, Raffle B. It says you have 200 tickets, each one costing $7. So we're going to subtract. So this other scenario, we'll figure that out on our calculator in a minute. That's game A. So on game B, each ticket costs $7. And let's see, one ticket will win $400. So one out of the 200 will win $400. Well, if you win $400, you're not really winning $400. You're winning $393 because it cost you $7 to get in. Plus, one ticket will win $290. So you have a 1 in 200 chance of winning 290 minus the 7, which would be 283. Plus, one ticket will win $50, so you have a 1 in 200 chance of winning $50, which is really, that's right, winning $43. And the remaining tickets win nothing. Okay, so here we go. Now, the remaining tickets winning nothing, well, what did I forget here? That shouldn't be equals, that should be plus. 1, 2, 3, so we've got 197 out of 200 chance where you not only win nothing, but it actually cost you $7. So we have to add that in. So we've got 4 things happening here. The first scenario, we only had 2 things happening. Either you win or lose. But this second one, we had 3 different prizes possible. But notice we had to subtract that $7 off of each one of those prize values because you don't get to keep that. All right, so now let's bust out the calculator and see which one of these has the better expected value. Let's do scenario A. 1 out of 1,000, which is really 0.001 times 96 plus 0.999 times negative 14. That equals a negative $13.89. Negative $13.89. So that's the expected value for scenario A. Now I'm going to type all this in. 1 out of 200 times 393 plus 1 out of 200 times 283 plus 1 out of 200 times 43 plus, and then if you lose, you have that's a 197 out of 200 chance times negative 7. Enter. And you can see in this one, we're losing $3.30. Okay. So remember, you are the customer in this raffle. You are not the person putting on the raffle. It says you can enter these raffles. So which one should you enter? Well, you're losing money either way, but it looks like B is the better one. You're losing less money. So I think letter B, or raffle B, is the right answer. Okay. Well, raffle B, submit, and we got it. Okay. So these take a little bit of time because you have to find each expected value. Let's jump up a couple levels and do a more difficult problem and see how we do here. Then let's jump up another level. All right, we're up to 68. Let's see how difficult this one is. There are 2 raffles you can enter again. All right, we're doing raffles again. Out of 100 tickets in raffle A, each costing $10, so we're going to subtract that $10 off of the prize money on each one. Let's see, 1 ticket you get $370, 1 ticket you get $270, 1 ticket you get $150, 1 ticket you win $40, and the other tickets win nothing. So again, this is going to be a lot of typing into the calculator, but I think we can handle it. Raffle B is $250, each costs $13, so we're going to subtract that off of each of the prizes. 1 ticket wins $540, and 18 tickets win $90. Okay, that's different. Not just 1 ticket. You have 18 tickets winning a $90 prize. The rest win nothing. Which raffle is the better deal? All right, well, let's give it a try here. Raffle A has 100 tickets, each one costing $10. So you have a 1 ticket. So you have a 1 in 100. Here's raffle A. You have a 1 in 100 chance of winning the $370 prize. But notice I'm not putting in $370, I'm putting in $360 because each ticket, remember, costs $100. Okay, let's see, you have 1 in chance, plus 1 ticket, you get 270, so 1 out of 100, you get 270, which is really 260. 1 ticket is 150. So 1 ticket is 150, which is really 140. 1 ticket is 40. 1 out of 100 gets you $40. Wait, I put cost $100. That's not right. It's cost $10. So if we win $40, that means we're really only winning $30. And the other tickets win nothing. So how many tickets are left? 1, 2, 3, 4. Out of 100 tickets, that's 96 tickets. 100. Now, when we type this in, oops, that's 0. You get 0. No, it's not 0, is it? Well, we talked about this before. It's actually, what is that? That's -10, because you had to pay $10 in order to lose. Whew. So there we go. That last one's going to be 96 over 100 times a -10, because we paid our $10 to get in. All right, let's do some typing and see what we get here. So I'm just going to type in 0.001 or 0.01 whenever you see one of these. So 1/100th, so 0.01 times 360 plus 0.01 times 260 plus 0.01 times 140 plus 0.01 times 30 plus 96 out of 100, or 0.96, I guess I could have typed in, times -10. So you type all that in, you get an expected value of -1.7. So -1.7, or you're losing $1.70 each time you play this game. All right. What was Raffle B again? Raffle B has 250 tickets. Where it's cost $13 for each ticket. One ticket wins this much, and then 18 tickets win this much, and the rest win nothing. So not as much to add up, but you can see it's a little bit different than what we've been doing. So let's take a look. 250 tickets. One ticket, all right, first of all, each one costs $13 this time. So we've got one ticket out of 250, so 1 out of 250 wins the $540 prize. But if it costs 13, what's 540 minus 13? That's, I think, 527, right? So actually you're winning $527. 18 tickets, so 18 out of 250, that's the big difference with this problem. I think that they think this is more difficult. You win $90. Well, $90 minus the 13 would be what, 77? So you're winning $77 when you win 90 because it costs you $13 to get in. And then everything else wins nothing, so that's 19. So you've got 19 winning tickets out of 250. So if you subtract the 19 from the 250, how many does that give you? I think that is 231, right? 231 plus 19 would give you the 250. So there's a 231 out of 250 chance that you win nothing. And when you win nothing, really, you're losing $13. So you just basically set up each possibility. Here's the grand prize. Here are 18 kind of secondary prizes, and this is the majority of the people. So let's figure out what that comes out to. 1 out of 250 times 527 plus 18 out of 250 times 77 plus 231 out of 250 times -13. You can see in this raffle, you lose $4.36. You lose $4.36 each time you play. So which one's the better play? It looks like A is the better play because you're losing less money. Remember, raffles are always set up so you lose money. That's the whole point. You're trying to, make money for the beta club or the whatever club is setting up the raffle. You're going to lose money, otherwise it's not a good raffle. This one is better. This one would be better for the people setting up the raffle. This one would be better for the consumer. And in these problems, you are looking at it from the point of view of the consumer. So in this one, we're going to say raffle A is the better deal. And that's it. Okay? So most of them are set up the same way. Again, this is DD.9. Give those a try. This is you have to use a lot of the different skills that we've talked about in this probability section in order to do this. You have to find expected value. And to find expected value, you just have to figure out everything that can possibly happen. You have to make sure all the probabilities add up to 1. You just have to make sure you take care of everything. figure out what's the better bet. Okay? So, thank you for watching. If you have any questions, just put them down in the comments, and I will talk to you tomorrow. Bye.